Okay, hi there. Here's Karsten, talking to you from Seattle, and I'm happy to be here. And I will talk about dynamic GIS layers with QGIS and spatial databases. So maybe let's talk a little bit about myself and how I came about to talk about this topic. So myself, I'm a geographer by background, and I have been working in many different locations. I'm originally from Germany. I've been here in Seattle and had my own small consulting business for the last 13 years. And I've seen many things from environmental, you know, uh, companies, nonprofits, government, and also in universities. So I've been working with open source for quite a long time. I have been working with map server, open layers, and PostGIS since 2008. And then I have experience with the SV stack and came to use much more QGIS. And so lately I'm almost exclusively using that. So how did we get here? So did I decide to talk about that? It wasn't a project for a client or something, but as a single consultant, you always need to kind of advance yourself, learn a little bit. And so I was inspired by what you see, inspiration for the talk. And there was a blog post and a video by Tim Sutton, one of the main programmers or in QGIS. And there were he was in that, he was demonstrating how to do dynamic queries in QGIS using a database view based on another layer, or actually a query layer that you can do with the DB manager. And then I found, reading a little bit lately about PostGIS in a little bit older book by Paolo Corti, PostGIS cookbook. I found some Python code, how they were using Python from within QGIS to access actually weather data from the open weather map. And these two kind of led me to investigate a little bit more, and I came up with this. And I think I have something pretty cool to present. And the topic is spatial database and dynamic layers. But when I was investigating that, I also looked at more simple things. I came across the geometry generator and adding data such as remote APL calls or GeoJSON or such. So because of the shortness of talk, I will not talk about it, but I will jump between my slides in the live presentation. And if you go to my GitHub account, which we'll post into that link in the YouTube later, you will find, these project files, data, and in SQL and functions that I produced for that you can replicate this. It could be a template for other calls. So basically, we will look at DB Manager connections and database views. And then we will also look at database views in a different way. There is some specific keyword. It's called a lateral. So there can be a lateral join in PostGIS since version like 9.3 that's available. And you can also use Python within the database. It's called PL Python. We'll take a look at that and how I created a view that will actually join an existing data set in a PostGIS table with a subquery, which is, calling a function. And that function actually calls remote data. And we'll have an example about weather data and temperature and then earthquakes. So let's go. I will skip these first 7 slides, and you have that, in if you download it from the GitHub. And I already, just to recall one more time, so we will do dynamic queries with DB Manager, look at PostGIS and Spatialite database views. And then the last thing will be that we will be looking at combining PostGIS with PL Python functions and an external API request. So if you look at DB Manager, which I will show, mostly, in the QGIS, you can connect to either, relational databases. There's a built-in connector to Oracle Spatial. Here you can see if you open this under DB Manager, you will see you can connect to Geopackages. You can connect to Spatialite files, which is like a special version of the SQLite database, and you can connect to PostGIS. Just for one note, for people who haven't used it, you can make connections to geopackages or Spatialite files right from the DB manager. However, with PostGIS, you still need to do that in the QGIS browser. So let's take a look. If you work with Spatialite, I also wanted to note there is an external application that has been around for a long time. It's called Spatialite GUI. You know, there's a link down here. If you download at least with the PowerPoint, the link is active. I think in the PDF it doesn't work. So, but all the links are also on my GitHub page. And let me just show you. This is the GitHub page. When I go to my dynamic layers with QGIS, you'll find all the information here. And you will also find these links here, and you will find the code for PostGIS functions right here. Just want to show that. Okay, let's go to QGIS. So how do you access the DB manager? Basically, you go here. Oh, sorry, I switched my user interface to German, but I think you will get what I'm talking about. So basically, you can see connected databases Geopackage, PostGIS. I connected to a remote database, which we will be using. And you can see the Spatialite. Or actually, that's non-connected, but that's fine. So you can create actually a query here on this data. If you select, let me just connect to this tracts. And let me just check where I got that. Sorry, that should have been there. I connect with my DB manager and say add connection, and then basically you navigate to where that file is. And sorry, I have to navigate here again because it doesn't let me. So I go to my projects and GIS classes. Sorry, that takes a little bit. I had to switch my laptop because it didn't work, and that's the reason for this trouble. So I can connect one here. So I just want to have an example that can be connected. So if you look in here, you can see the table. You can click on that and actually make a query. So you could say select star from, and then put in point flooding. If I do that, then I get these data. And you could also have that, I'm not sure if people are aware of this, you can load that as a query layer. If you say that, there's two things that you need. You need a unique ID and you need a geometry column. So I could say, I want that query 1, and then say load. So that should give us a query layer. Sorry, I think that has the wrong projection. And it actually should show up. I don't want to mess with it yet now too much, but that's how you can learn. I mean, that's how you can create a query layer. So I just did that for the Seattle tract. So if I have here a SQLite file connected, I can basically run a query, and I can just use this one instead, since the other one was messing me up. In DB Manager, I go to my Spatialite file, and I need to connect to that tracks. And then let me just do that. If I run that query that I was about to show, which is this one, select star from tracts where population in 2010 is bigger than 7,700, it would select just that one tract. I just did it that way. And then you have an option to use any of the functions that the spatial database has. And if you have PostGIS, you can wrap around all these functions you have. For example, if you wrap around the geometry function stBuffer and then use 900 meters or 900 feet in this case, do minus, which is an inside buffer, it gives you basically this, that you have this inside buffer. So I just wanted to show this simple example before we go to something more complicated. So let's maybe go back to my slides for a second. So I don't want to talk much about PostGIS, but basically you can store spatial objects in here, and you have a whole lot of spatial operations you can use via functions. Then I showed kind of what wasn't really working. Here is in the slides, when you have connected the settled tracts, the query that I could buffer inside 900 feet, the geometry, and then select just one of the tracts was, which I did by population from census 2010, bigger than 7,700. So that was an example I wanted to show. So if you were to add something like a database view, a view is like a temporary, glance at the data. It's not not a permanent table, but it's an SQL query that can be stored, and you can retrieve data from one or more tables. So if you want to use any of those in QGIS, you should add a unique ID, and you can do that, generate one if you don't have one by that SQL construct row number in brackets SGID. So that is something to keep in mind, that otherwise it will not correctly work often. So I wanted to show you now one of the three examples we have. One is, using a Spatialite file, and I was creating two query layers. So what we have here, let me just show it. Basically what it does, we have like one location file in points, and then we have two views. One is using the geometry of the point and buffering that by SD_buffer around it. You can use similar functions in Spatialite, just like in PostGIS. And then we have one where I query those circles that were created in the first view by intersecting them with the Seattle road network. So there's two data sets. One's the point and one is the road data network. So let's take a look at that and make that run. So I have this example here. When I go here and switch off the OpenStreetMap, I could go right here and let us edit these points for now. I will first delete those points so that we start with 0, save it, and then refresh. So what I have here is the road network. So I will digitize one point, and it takes as a parameter the radius I want to run that buffer around. So I'd say 200. Then I make that, I save that. And once this is updated, it will create that buffer layer, which is this one. So basically take a short look at this, what it is. Maybe you cannot see that so quickly, but it says select point and then an ST buffer around the geometry. And as a radius, it takes this field, radius that I entered. So we can have a variable radius. And then that second thing here is a selection. It's a view that says select from the points and the roads where it does intersect these circles. And if I update that map, those roads, I can take off the point, I can take off the roads, and this is the buffer, sorry, and this is the intersected road. So basically from that point, you could dynamically create, or we actually dynamically created this. Just to, you can do multiple ones, but in terms of time, I need to go to the next one. So you have that all in a GitHub account and can download that example later to try it out for yourself. So now we are connecting to a PostGIS database. And let me just go to what's happening here. I will go. So let's explain that from the beginning. We will use a custom PL Python function and an external API request. And there's certain prerequisites that you can run that. We need a lateral join in the view. So that's available from PostGIS 9.3 on. PostGIS extension installed, Python 2.7 or higher, or you could also use Python 3. My example is Python 2.7, and you need to have the PL Python language installed. So what will happen in this? We have actually an open weather API where you can get weather data from an external source. And I will wrap that into a function in Postgres when, that is Python, that will actually run a query based on the point I added in a location layer. And then I have a view that then will display, the view is basically a query on the point, running, an API call to Open Weather Map, getting the closest weather data and displaying that from the view, as I added a view as well into into QGIS with the actual current temperature in degrees Celsius, and then also calculated the distance from there. So let's just let that show. You can go put back to the slides to see like more explanations how that works, but I think it's better to see what it actually does. So if I go to, this is a remote server, so hopefully it won't be too slow. I will click on my, okay, let's go to this point here. So let's just go somewhere. This API is available for USA only. So if I go, this is my PostGIS point layer. I will click on adding one here in Arlington. So now the remote server, I have to give a unique ID and put a name. So I say, okay. So this is already showing up with the ID. So what you need to do is now save that. So I have two views here, and I need to zoom in more to make this a little bit more visible. So first of all, the first view is what I created with this PL Python functions. I will show that in a second. And basically, I can show that in a database. It did that call, found this information, and added it to the view, and then also used ST distance functions to calculate the distance from that point. And then I have a second view which takes these 2 points and generates a line that shows here up in red.
Hi, Karsten. I'm sorry to cut in. We only have about 2 minutes left. I just wanted to let you know that.
Okay. So basically, I would say, since we're running out of time, you can go to the GitHub page and check out these examples. The second one is about US earthquakes. Let me just show what I did here for, it's a little bit slow because of the remote server. Let me just go back to the slides. And basically, I wanted to show you, this is the weather API where you can get an HTTP request and get JSON back. This is the request you can do. You can do that, from all the examples I have on GitHub. Basically, this is how the PL Python function works. So basically, the first and last line is a wrapper inside is Python, and you see where it creates a call to that API. And then basically what you see is, first example of where the map gives you that JSON back. And if I create that function that you've seen in black before, I can run, for example, select get weather all as my function and get back that result down here. And then if I wrap that in a view, which I added to QGIS, then it is what you have seen before. So basically the view looks like this. Everything in red is what we have from these points. The orange is, the digitized coordinates is in orange. The red is, just from PostGIS, the geometries I generated, and the green is what you get from the API call. So for now, since I ran out of time, I want to leave time for questions. And really, this can be much better understandable if you go to the GitHub and try it for yourself and get in contact with you if any of these examples don't work. Thanks a lot for your attention, and I'm happy to answer any questions.
Karsten, that was great. It's making me want to step up my Python game a little. So there was one question. Is there a Spatialite GUI for Mac? I don't know if you're able to answer that question.
So I'm not aware of, since I'm not a Mac user myself, unfortunately, I don't know. You can do most things now in the DB Manager. Previously it used to be that you couldn't create views and such. You can do that. But the Spatialite GUI, as far as I know, is only for Linux. And there's a source code. If you get it to build on your Mac, you can do it. I don't know if there's pre-packaged ones.
Last question, just really quick. What about the speed to load views, database views? Typically, if it's a very large table, things start to get a little bit slower. Have you experimented at all in trying to speed that up?
Well, the database view also uses, the unique key or the indexes in your original table. So if you set, your indexes in those, it should be fine. If you have this on a remote server and we do API calls, API calls only happens if you digitize a new point, and then it creates it. After that, yeah, it still does that API call, because actually what you will see in here is always the current temperature at that location. So yes, it can be a little slower, especially in this case.
Well, thank you very much. That was really interesting. I'm sure there's going to be a lot of people flocking to your GitHub repo to take a closer look at this. So thanks for participating in the conference.
Okay, thanks a lot.